Alright, we're going to do a lesson on radicals, complex numbers, and roots, and it's a combination of two sections in the book. Okay, so some property of radicals. If you take a square root of a square, those cancel, and so you'll end up with a. If you have a square root of two numbers multiplied, you can separate those. Square root of a times the square root of b. And then if you have, and that also works for division. So here we're separating, here we're going to put back together a divided by b. Alright, so example 1 that we have over here, let's scoot over just a little bit. And we're going to use the second one, we're going to separate. But what we want to separate is, we want to separate out the perfect square. 25 is a perfect square. Take its square root, you get 5 root 3. Example 2, we can't have a denominator that's irrational. However, 3 will divide into 15. So you got 15 divided by 3, which is the square root of 5. And then the last one, we're going to reduce 7 times 35. Now you can multiply by 7 and 35, but what I know is that 35 is actually, I'm going to put this all under one radical. 35 is 7 times 5, and what we have, 2 7s equals 7 root 5. Okay, so here's some notes. We're going to start with talking about rational and irrational. We're going to learn today about rationalizing a denominator, which means make sure your denominator is an integer. And what happens is a conjugate is something that you multiply to basically cancel out the irrational part. So we have square roots of 2. If this was in a denominator, this would not be allowed. But you multiply by the same expression, but with the sign changed. So let's work through this one. So what we have here is square root of 2 minus 3, square root of 2 plus 3. They are conjugates of each other. And what happens when you FOIL these is square root of 2 times 2 is 2. And then you FOIL it, and what happens is this looks like a difference of square models. That's because it is. The 3 square root 2's cancel. They had to be a 0. And this ends up being equal to negative 7. So let's put this one into practice. Okay, so I did mention that we don't want radicals in the denominators. One way to undo a square root is multiply by another square root, because now you have a b, and it's a square root b. Now these are all very symbolic. We will put some numbers to them. So we talked about conjugate a minute ago, and for numbers 2 and 3, what we have is the need to make sure we have an integer in your denominator. So you're going to multiply the top and the bottom by conjugates. And why the top and the bottom? Because we don't want to change its value. So when you multiply top and bottom by the conjugate, you're essentially multiplying by 1. And the conjugate is simply a change of sign in between here. Just like that. Alright, so we need to simplify these. We're going to rationalize them, and I'm going to zoom in just a little bit on this first example. And I want to multiply this by the conjugate, top and bottom. So I've got 5 plus square root 2, 5 plus square root 2. We're not changing its value, we're just changing its looks. I'm going to distribute the 4 through the numerator and FOIL the bottom. However, since the O plus the I from FOIL are the same but different signs, they're going to make a 0, so you don't really have to do FOIL, you just do the FL part of it. And so we'll simplify this, and you get 23 in the bottom. Okay, so this one, example 5, does not have a conjugate. It's just one number. So what we're going to do is just multiply that by the matching square root, like so. square root of 2 times the square root of 15 is 30. And that's 15, and that's as simplified as that one gets. All right, we're going to solve this equation. It's already factored. We already have a square, like so. So what we're going to start with is we're going to divide by 3. That's your first step for this type of problem. Okay, so when we divide by 3, you end up with x minus 2 squared equals 40 over 3. All right, so then we're going to square root both sides. Now when you square root, when you're solving, you're going to put a plus and minus in front of the number side, and I'll show you what we mean here. X minus 2, don't really need that parentheses right there, equals plus and minus the square root of 40 over 3. Okay, I've got a radical in a denominator, and I don't want that. So I'm going to rationalize here. All right, I'm going to extend that, do the 3 over 3 inside, because I can, really. And I've got x minus 2 equals plus or minus. Now, I want to go ahead and simplify 40 right here. 40 is 4 times 10, which is 2 root 10. So 2 root 10 times 3. My denominator down here turns into just a 3. And then I'm going to add the 2 to both sides. So 2 root 30 over 3. And you could find a common denominator there if you wanted to, and make the 2 6 over 3, and then you could put it all together. Okay, so let's talk a little bit about something totally different. Complex numbers. We've always said that taking the square root of a negative was bad. However, it is part of the complex realm of numbers. They're called imaginary numbers. And the way we show this is square root of negative 1 is going to be equal to the little I right there. We use I for imaginary. And what we're looking for is we're going to be solving problems with i's. There is a use for them in electrical engineering. And we're also going to be rationalizing, because they are not rational numbers. So I squared would be the square root of negative 1 times the square root of negative 1, which means square root of negative 1 squared. So that's 1, negative 1. This is going to be a very important thing for us to use as we're solving problems going forward. So first of all, I is the square root of negative 1. Now, what do I do when I have something like this? How do I express it? The first thing you're going to do is look at that negative right there. You're going to change it to an I, and then just leave the square root of 5 as it is. Alright, so let's solve a couple problems. When you're solving, you're going to get 2 answers, because, let's just talk a little bit about this. If you had equals 25, there are 2 numbers that give you an x. It'd be plus or minus 5. Same deal with imaginary numbers. So we're going to square root both sides, which gives me x equals plus or minus, get rid of the square right there, plus or minus square root negative 13. The negative is I. So we're going to take the I out, leave the 13 under it, and that's our answer for these 2. Now, this little complex number thing here, we're going to mark that out. That was a bad cut and paste job on my part. Alright, so we are going to now solve example 8. I want to start with subtracting 33. That gives me negative 30. And then we're going to divide by 5. Negative 6. Starts to look a lot more like example 7 now, doesn't it? Take square root of both sides, plus or minus, square root negative 6, plus or minus I square root 6. So we've talked a little bit about imaginary numbers, but let's talk about the complex number. The form that a complex number takes is a plus bi. B is the coefficient for the imaginary part. When you're adding like this, you're just going to treat that I like any other variable. We're going to treat it like an x and just collect like terms. So 9 minus 6, and then negative I plus 7i, which is plus 6i. And the same thing happens down here. But if we have an I squared, what we want to do is replace that with a negative 1. It's very important that we do this. So let's multiply. So negative 40i plus 45i squared. I squared is negative 1, so that changes the sign right here. And we generally want to write the real part of it first. And so that's what we're going to do. Alright, let's look at this last one right here. We are going to FOIL these. You're going to find out what happens. Usually when we FOIL, you end up with 3 terms. With these, you're going to end up with 2 terms. So let's FOIL this. So we get negative 32 plus 56i plus 8i plus, I'm running out of room, minus 14i squared. The I squared is negative 1, which means this changes signs right there. So I've got negative 32 plus 64i plus 14. We'll add our real parts of it, which is a negative 18 plus 64i. Alright, so a complex conjugate we're going to treat the same way as a rational conjugate. The conjugate of a plus bi is a minus bi, and vice versa. If you have a minus bi, the conjugate is a plus bi. Okay, so what we have here are conjugates. These two are conjugates of each other. When you multiply them, 9, okay, the inside and the outside cancel, so we don't even need to do that. Minus 4i squared. I squared changes the sign to a positive, and that is 13. So what this gives us the ability to do is to write this in standard form, but with a rational denominator. So multiply by the conjugate and FOIL. So when we FOIL this, we get 15 plus 20i plus 3i plus 4i squared. And when you're doing a conjugate, you only need to do first and last. So we got 25 minus I squared. Alright, so for the real part, 15 right here, this 4i squared is actually negative 4, because the I squared is negative 1. So we have 11 plus 23i, and in the denominator, what we have here, this is a plus 1. We'll have 26 in the bottom, and that is the lesson on rationalizing rational denominators, complex numbers, a lot.